Hi everybody. My name is Nikita Pietrow. I'm a senior research engineer from the Manufacturing Technology Center, and I'm really excited to be able to share some of the work that we've been doing over the last few years towards developing a framework for operational digital twins. I'm sure everybody on the call is already sold on the transformational potential of digital twins, and we have probably all seen the complexity involved in their development. And what we're increasingly starting to see is that complexity in development is actually carried through all the way to operations and maintenance of digital twins, which results in organizations struggling to adopt and transition them from a proof of concept into an operational asset, and therefore fail to extract the full value and potential of those digital twins. And this is exactly what we're trying to achieve with this framework by introducing the sort of life cycle based approach to digital twins through this framework. So in the presentation, I'll give you a really quick introduction to the MTC, talk about some of our journey and case studies and our previous experience, and then really dive into the framework and share some of the highlights from this document that we're putting together. But really what I hope to achieve today is actually to capture some feedback and ideas from all of you on the call. So what I'll do is during the presentation, you'll see a QR code pop up to share feedback on some of the content that I'm presenting, some of the content from the framework. And I'll also put the same in chat now. So if you want to open that on your laptops, you can do it via the link in chat. So kind of jump straight into it. The MTC is an independent research technology organization and part of the High Value Manufacturing Catapult. And we've been operating for around 14 years now from our head offices in Coventry, which you can see on the kind of just in the background to that slide. But we also have satellite locations in Liverpool, which is actually where I'm based, and in Oxford. And our role at the MTC is to accelerate the adoption of technology across industries in the UK. And for myself, based within the digital engineering team of the MTC, we look at anything to do with data, from data capture to infrastructures to AI, inspection and modeling and simulation. So naturally for us, digital twins as a system of all of those components combined together to achieve a new functional objective is something that we've been looking at for quite a few years. And really for us, that journey with digital twins has started way back in 2015. We started by building really simple supervisory digital twin demonstrators for the aerospace and automotive sector, looking at collecting data from across the manufacturing digital thread, from ICT systems and sensors and devices within processes. We then started building more advanced visualizations on top of these digital twins, making better use of our data for decisions, and improving that visualization, and even looking at some immersive visualization tools. And then about 5 years ago, we started adding modeling and simulation capability into that sort of digital twin mix by building integrated process and plant simulation models, cost models that are able to look forward to build predictive digital twins, and in some cases, even interactive twins that can directly control or actuate assets in the physical world. And now we're sort of trying to take all that learning and look at adoption, and particularly sort of the best practice to make sure digital twins are built correctly, future-proofed, and can be maintained in the long run. And as you can see, over the last few years, we've delivered 14 different projects across different sectors, and just some examples of those. We've looked at sort of maritime, underwater products and services, fast-moving consumer goods, pharmaceutical packaging, and even full-scale factory twinning for aerospace and automotive customers. There's just some examples. But the one, in the interest of time, I want to sort of zoom into is that pharma packing system at the bottom right. It's probably my favorite example of a digital twin that we've done at the MTC, and it introduces a thermal manufacturing digital twin, specifically looking at rapid adaptive packaging of pharmaceutical blister packs. In this case, the challenge in the process is a heating step where a blister material is heated and formed to form the blister pack, and a tablet is then dropped into that heated material. Of course, that is a critical step for safety of the process because we need to make sure that when a tablet goes in, it is done at a correct temperature. But there are variations in the process, in the material, in the environment, which makes that a really difficult thing to control. So as a result, time is typically set conservatively, taking sort of the worst case scenario and slowing down the line to make sure that when a tablet goes in, it is done at a safe temperature. But through a digital twin, we can instead collect live data from sensors and devices on that machine, analyze data with the help of real-time process simulations to predict the temperature in process, and actively control the process by speeding up or slowing down the line, turning cooling on and off, to make sure that when the tablet goes in, it is done at a safe temperature, but at the same time as quickly as possible. So that allows us to achieve faster processing times, reduce changeover by avoiding trial and error at each changeover, and instead going for a data-driven approach, and ensuring that when a tablet goes in, we're 100% confident that it's done safely. So a really good example of a interactive digital twin where we collect data from the physical line, analyze it with the help of predictive models, and then control the physical process directly with the help of those process simulations. And what we've learned from projects like this is that, while great and incredibly powerful, a lot of these digital twin projects, including the ones that we've done, get stuck at proof of concept, and they're limited by some of the challenges that actually occur after development. So the challenges in operating and maintaining these digital twins. So questions like, how do we keep the asset secure and up to date? How do we make sure it's future-proof and flexible and we can adapt it? How do we inevitably manage change when it occurs? So if we have to swap components out, or if we have to add additional functionality, how do we manage that in a live asset? And most important of all is, how do we get people to trust the digital twin in the first place, so that it can be adopted and it will be used day to day, and many other challenges. And when we looked into this, we found that there wasn't a lot of guidance around that topic, specifically on what happens when your asset goes live. So we set out with that goal in mind, so to fill in that gap in available guidance to help organizations build digital twins that can be maintained and operated in the long run. The first thing we did was reach out to our membership group at the MTC, and you can see some of the companies that are our members and the ones that we spoke with highlighted there. So we conducted workshops and interviews with the likes of Rolls-Royce and Amy based on their previous digital twin projects and experience, and then kind of wider conversations with the rest of the membership group members highlighted there, to try and capture some of their ideas, some of their experiences and lessons learned. And one of the first things we talked to them about was, what are some of those challenges? Of course, there are many, but what are some challenges that organizations are faced when they try to adopt digital twins? And you can see that there's a very broad range there. You can also see on the right-hand side a QR code has appeared. So this is where, if you don't mind scanning that and sharing some of your thoughts and ideas around the content of the next few slides, that would be really valuable. But yeah, there's a link in chat as well if you prefer to use that instead. In the interest of time, we won't dive into every single challenge, but you can see they range from technical and data challenges around connecting to the right data and building your digital twin in a way that it is interoperable on the right infrastructure, has access to the right volume and rate of information, and can be updated and maintained, to privacy and security concerns, to complex standardization landscape, and of course, really big organizational challenges around the culture and mindset around digital twins, lack of skills, lack of training, and lack of clear roles and accountability for maintaining digital twins, just to name some of those. And then finally, of course, challenges on resources, just the cost and affordability of digital twins, but also interestingly, quantifying the benefits and the return on investment on some of these digital twin projects. So a really broad and landscape of challenges, from technical to non-people and process challenges that we have to address. And we wanted to create something that it's not going to solve all of those, but it at least can help companies discover some of those challenges and put plans and things in place to help mitigate some of them. What we created was a life cycle concept. So the idea of a digital twin life cycle, a typical flow of projects that the digital twin projects go through, from getting your initial idea to eventual end of life. So quickly to go through some of those steps, we looked at step one around ideation, looking at creating your business case for the digital twin and engaging your initial stakeholders. Moving on to design, where we'll put together the solution architecture, capture requirements, and downselect the technology. Developing all those components individually, integrating and testing them, And then moving into deployment, where we launch it into operations, and hand over to an operational team who is responsible for maintaining the asset. And then eventually we move into operations, and that's really where we start to extract the value from our digital twin, and utilize it in day-to-day operations. But also, this is where it's really important to ensure that the digital twin is monitored and maintained and improved as needed. And this is where change will happen inevitably. There may be change in the physical process. There may be change in some of the tools and technology you're using. There may be new legislation or kind of any other vector of change that is introduced. And that's why it's really important to have a good change and configuration management process that sits over the top of that life cycle and allows us to go back a step and update some of our documentation if needed. Or if it's not a big change, then just continue operations as we're doing. Or then change may be so significant that we have to think about end of life and decommissioning our digital twin, or repurpose it for something else, for example. So that life cycle was introduced as part of that framework, and really the framework is then built around this life cycle concept. I've said the word framework a few times already. So what we mean by that is a structured guidance document for this life cycle based approach to digital twins. We're assuming people are coming to this as somebody that's looking to develop and operate a digital twin as part of it within their organization. And the message we try to get across is that these are really complex systems of multiple interconnected components, which makes them quite difficult to not only build, but then maintain in the long run. And therefore, organizations sometimes struggle to extract that full value. So it is important that it's a life cycle approach. You start to think about some of these things at the very beginning of your project, not at the end, only once the challenges are sort of realized and you face the consequences. And what we hope the document will do is provide a resource for planning and managing new and existing digital twin projects. And the really big part of it is that we're trying to not reinvent the wheel. There's already a wealth of really good resources on the Digital Twin Hub and through other thought leaders within the digital twin community. So one of the things we're trying to do is to reference and point to all of those tools and templates that already exist. So one of the questions there on the poll is around any others that you've come across that you think would be valuable to add as part of this framework. And on top of that, we are, of course, then adding some of our lessons learned from our projects and also from some of our members. And hopefully, kind of together, that document can help ensure that projects around digital twins are successful and they can be maintained more easily in the long run, kind of treated in the same way you would treat their physical counterparts. It's a 40-page document, so of course I can't dive into every single point today, but I wanted to just draw out some of the really key topics that we discussed within that framework. The first one is a user-centric approach. So it's really critical to understand the requirements of your end users at the very beginning of your digital twin project, and then build your system, build your architecture around those components. It seems quite an obvious one, but actually quite often those are either not captured or not captured to a great level of detail. So we've partnered with the University of Loughborough and their people-led digitization group to help build some of those tools to assess the stakeholders and some of their needs and requirements, and then make sure we build around those. The second biggest topic we talk about is modularity and scalability, especially something that resonated with our membership community was around the ability of the requirement for a digital twin to scale, change, and improve as your processes evolve and as you build kind of your maturity and knowledge around digital twins. So we talk at length around unified namespace and the idea of a unified, scalable, efficient data architecture with really clear naming and data located in a hierarchy at the core of your digital twin, around which you build all of your different other components. And that's actually something we've taken through into a validation project at the MTC. So by validating our own framework, by building a new demonstrator. So we're following that exact concept by building this core infrastructure that supports a wide range of different components, specifically using the UNS concept. And yes, there's a little bit more effort up front to build something like this, but it gives that long-term maintainability. We also talk a lot around data and the importance of understanding how data flows through your digital twin. We think about it as a kind of the lifeblood of your digital twin. So understanding where data comes from, how it's processed and managed within the digital twin, and how it flows all the way through to the end. Well, I've already talked about change management and the importance of this. Security by design, of course, making sure we think about it from the start and build some of that functionality in rather than thinking about it at the end during operations. There's a lot there around monitoring of the performance, security, and value of your digital twin to ensure that it's performing as expected and is still delivering the value that it set out at the beginning. And if it doesn't, then again, we look at change management and what changes have to be made, and many, many others. So hopefully once we publish this in next year, all of you will have access to this document, and would be really good to get some feedback on some of those concepts. And just to wrap up, so this framework that I've talked about today is part of an ongoing project at the MTC. So we're really looking for feedback, lessons learned, ideas, resources, things that we can point to, and things that we can build into the framework. So through that QR code or through directly reaching out to us, please do share your insights and ideas, or any feedback. If you don't agree with that life cycle, for example, if there's a critical step missing, those are the things that we really want to capture at this point. As I mentioned, the goal for us is to publish this as a white paper at the beginning of next year, probably as two. One as a white paper and one as a sort of the toolkit that with all the checklist of things that you've got to do as you're following through your digital twin. So look, I guess keep an eye out for that at the beginning of 2026 when we publish this. And some contact details there for myself if you want to reach out or connect with me on LinkedIn through the QR code.